Hey everyone, welcome to the first video on our brand new NumPy for Data Science series. If you're diving into Python for data science or machine learning, NumPy is going to be your ride or die. No jokes there. You have to learn NumPy if you want to venture into data science or machine learning or deep learning or generative AI. Now, for this series, we are going to break this down from absolute basics. I'll be taking real world examples, we'll be solving some challenges together, and we'll learn a couple of tricks along the way. So grab a coffee if you must, and let's kick this off. So what is NumPy? NumPy is a library in Python. It stands for numerical Python. Why do we call it numerical Python? Because it's a library for numerical and scientific computing. So here in NumPy, we have this data types called as arrays. These are multi-dimensional arrays. So your array could be two-dimensional, three-dimensional, five-dimensional, 100 dimensions there could be in an array. And these arrays are faster. They're very fast for mathematical operation. So you can do linear algebra, stats, and much more. So why do data scientists love NumPy, or why do we have to even learn it? So when you're working with millions of rows of data, which we will be working with, if we intend to work on machine learning or deep learning algorithms, speed matters. And NumPy give you that speed boost. So you have list also, which is comparable to array data type that we have in NumPy. But compared to a Python list, NumPy arrays are faster, they are more memory efficient, and they have built-in math operations. So let's first look at how to install NumPy. If you don't have NumPy already installed, you need to open your terminal and there you can say pip install NumPy, or you can do it right here from your Jupyter notebook as well. So pip install NumPy and run it. So if you are using Anaconda, NumPy is actually already installed for you. So if it is already installed, what it will say, requirement already satisfied, that you already have NumPy installed. So let's see if the NumPy library we can import or not. So import NumPy. And generally for NumPy, we use the alias NP. So let's stick to that, NP. Great, this works. Now, let's create an array using NumPy. So NumPy, as I said, supports this array data type. Array is homogeneous in nature. It holds the data of the same value. If I have to create an array, which we'll again discuss in the next video, how to create different arrays in NumPy. But let's quickly look here as to how an array looks like. So I'll pass a list to this np.array function. In the output, it will return us an object of NumPy array class. Let's just check that. First, let's go ahead and print this array. And now if I check the type of this array class, array variable, I can see this array is nothing but an object of this NumPy dot nd array, n dimensional array class. So this was a quick sneak peek into how an array looks like. A more detailed discussion we'll do in the next video. Now you might be wondering that this looks pretty much like a list, so why bother about it? So let's do a comparison between the Python list and the NumPy array. So first thing is speed. Python list is slower while NumPy array is faster. Now you must be wondering that why NumPy arrays are faster. So as I said, NumPy arrays are of homogeneous data type. That means all the items of the NumPy array would be of the same data type. So if you're creating an array with, let's say, a string, then all the items are supposed to be string data type. If you're creating an array with numbers, integers, all the items have to be integers. If float, all the items have to be float. So because the items are of homogeneous type, the elements are stored in the contiguous memory blocks, while Python list is heterogeneous. So which adds this overhead in type checking and memory management. So that's one reason. Then NumPy operations are implemented in C. So C language is faster. Uh, they are compiled much faster than the equivalent Python code. So for that reason also, NumPy is faster. So the backend of NumPy is C program. The second difference is type consistency. So Python list, as we all know, that supports heterogeneous data type. In the same Python list, you can have integer also, string also, another list also, while NumPy arrays are homogeneous in nature. You can have NumPy, any data type in a NumPy array, but all the data types in a given NumPy array have to be of the same data type. So all strings or all integer or all float. Memory. So Python list, more memory is used. NumPy arrays is more memory efficient. This ties back to the discussion we had earlier that it is a continuous memory location in the case of NumPy. Why? Because it's of the same data type. And math operation. So if you have to perform any math operation, in the case of Python list, you have to do looping. So if you want to do some math operation on all the items, let's say multiply all the items by 2, you have to apply loop. While in the case of NumPy array, this is vectorized. So you just say multiply by 2, and without using the for loop, you can apply the operation, the mathematical operation on all the elements or items of your NumPy array. So let's say we have this sales data. Let's go back to our Jupyter notebook. Let's say we have our sales data. This is a list. So this is how my sales look like. And I want to give everyone a 10% bonus. So 10% of the sales. So how I would do it in regular Python without using NumPy. If I were to use, let's say, list comprehension, I would say, or let's just use the regular Python. So I'll say for S in sales. So I'll go over each item. S multiplied by 1.1. And then I'll assign it to a variable. Let's call it bonus. Empty list I'm creating here. And then I can say bonus dot append this value. And now if I check what is there in bonus, this is what I've got. So this works. This does the job. But let's see how this same thing we'll do using NumPy. So I'll say np.array. Array is a class in NumPy. And what it does is it takes sales and converts this to array. And let's just save it in some variable, np underscore sales. Again, let's just quickly check the type of np underscore sales, and you can see it's a object of ND array class. Now we want to apply this operation. So how we would do it on this array? Sales multiplied by 1.1. And this is the output, everyone. We're getting a NumPy array in the output. And just with this line, without any for loop, we were able to get the bonus. So this is one line, more clean, more readable, and of course, much faster. So let's run a quick performance test. Nothing fancy, just a sense of how fast NumPy is. So for that, I'll import the time module. Let's do that. Import time. And for the time, we can say print. Let's do a F string here, Python list time and minus start. Let's run it. We have to execute this first. And as you can see, right now the time is coming 0. Why? Because the data is very small. So maybe let's add some more data points here. So what I'll do here is I'll create a list. So I'll first create a range of numbers. Maybe, so here we have it, the Python list time, which is 0.16 seconds. Now let's try the same thing, but with NumPy arrays. So we already have our sales. Let's just copy paste it here once more. And now the calculation is simply NP underscore sales multiplied by 1.1. We can save it down to another variable, NP underscore bonus. So let's put a start here, start time. And the end time. Let's print the difference. ND array time and minus start. If you want to convert it to milliseconds, you can multiply it by 1000. You see, this is much faster. That's why data scientists live in NumPy. So that's all for this video. Coming up next, we'll explore how to create NumPy arrays. So there are different ways in which you can create different functions to create NumPy arrays. We'll explore each one of them in the next video. Hit the bell icon so you don't miss it. If you enjoyed this, smash that like button, subscribe. See you in the next one.